All right, welcome to our next unit, everyone. So in this unit, we're going to be talking about another kind of function called a rational function. Rational function. Now that might seem like a weird word to use to describe a function. Normally in everyday speech, when you say somebody is rational, that means they're very logical and they think things through using logic. But that's not what it means in this case. In math, when you hear the word rational, look at the root of that word, ratio, R-A-T-I-O, ratio. And that's kind of where it comes from. So a rational function is a function that's a ratio. And a ratio is just another word for a fraction. So a rational function is a fractional function, a function that's in the form of a fraction of two, usually polynomials. Okay, now these are really neat functions. So I wanted to start off by showing you some graphical features and pointing out to you kind of the neat things that a graph of a rational function can have, some behaviors that it has. So take a look at this Desmos graph that I got here. So here's kind of a rational function. Now, if you want to see what the actual function is, you can look here on the left-hand side. And in the left-hand side, this is the function, x squared over x squared minus 16. So that's a rational function because it's a ratio, it's a fraction of two, in this case, polynomials. Now, what's more interesting, though, than the equation itself is actually the graph. So if you look here on the right-hand side, here is the graph of our rational function. And it looks pretty crazy. It looks like you got three different sections. You got a section here on the left, okay, this kind of curvy part here. And then you got another section here in the middle, kind of this upside down U-shaped graph, looks almost like a parabola, kind of. And then you have this other section here on the right that's kind of curving out this way. And the three sections don't look like they're connected at all. They look like they're completely separate. And that's kind of one of the neat things about a rational function, especially when you look at the graph, is that you can have these kind of disconnected graphs that have a lot of different behaviors and features. Okay, so here's an example of a rational function graph. Now, let me put in a couple of lines in this graph to point out some specific other features that a rational function can have. So I've added on these three lines. Now, these are actually not part of the equation itself, but we often draw these lines, and that's why I draw them dotted, to emphasize that they're not actually part of the equation. But they help us frame our thinking about the behavior of rational functions. Okay, so take a look at, first of all, these two vertical lines. So I got these two blue vertical lines. I got this line here, coming up and down here. Then I got one on the other side here, these two blue dashed vertical lines. Now notice how the graph behaves. So like this piece on the left, notice as it gets closer and closer to 4, where that blue line is, it shoots up really fast. Okay, but if I were to scroll this graph up, what you would see is that the red graph, which is the actual graph of the function, never actually will touch this blue line. It'll get closer and closer. It'll shoot up, keep shooting up really far, and as it goes further and further up, it'll get closer and closer to this blue line, but never actually touch it. And the same thing with this middle section down here. As it gets closer and closer to the line from the other side, from the right side, it dives down. It goes down really far. And same thing again, if I were to scroll down, keep scrolling down, you would see that that red line, which is our actual graph, never actually crosses or touches that blue dash line. And the same thing with the other blue line here on the left, on the right here. The graph in the middle dives down. It'll never actually touch that blue line or cross it, but it'll get closer and closer to it. And this section here, or this red section here on the right, as it shoots up, it'll get closer and closer to that blue line, but never actually touch it or cross it. Okay, so a lot of times when you have rational functions, you have this kind of behavior where you have these kind of lines that section off your graph in different sections, and they kind of act like barriers or walls to your graph. Like different sections of your graph will get closer to the wall but never actually touch it. It kind of acts as a border between different portions of your graph. And those lines actually turn out to be really important when we start to talk about some of the behaviors of these rational functions. Those lines are called asymptotes. And that's kind of a funny word. So let me write it for you. Asymptote, asymptote. And so the plural is asymptotes. So that's a Greek word, asymptote, and it kind of means continuously falling together. And that's kind of a weird description, but what it means is that you have your graph, your curve, which is our red curve, and the blue asymptote line getting closer and closer, falling together, but never actually crossing or touching. So these asymptotes, these lines that section off our graph into different sections, those are going to be really useful for us to find. Okay, now notice I drew this other purple line horizontally going across, and it kind of has that same kind of behavior. So for the red part of our curve on the left here, as you go further to the left, now I don't show this, but you can scroll over, keep scrolling over. Same thing will happen is it'll get closer and closer to that purple line, but it will never actually cross it or touch it. And the same thing on the right side here, that purple line going to the right. This red portion of our curve will never actually cross it or touch it. So this purple line is another kind of asymptote as well. This one goes horizontally as opposed to vertically for the other two. Okay, and again, notice how it kind of sections off the graph into 3 sections. So when you have a rational function, you can get all this kind of crazy, interesting behavior in the graphs. And I wanted to show you the graphs first before we even talk about the equations for the functions or how to manipulate them, because the graphs can often show us some interesting behavior, and that kind of guides us as we talk about the different features when we start to talk about the algebra. Okay, so these are graphs of rational functions. So now that we've seen kind of some of the interesting things that you can have with graphs, let's go ahead now and take a look at the actual functions themselves and talk about how you simplify them and analyze them algebraically.